Hello students. Today in the series of learning database management system, we are going to study set difference in relational algebra. Set difference, gives us the facility to find out a tuple which is present in one relation but not present in another relation. So set difference, it is same as in relational algebra also. So if we are having two tables, it gives us the facility to find out those rows which is present in one table but not present in another table. It is again a fundamental operator because as I told you, uh, the work which set difference can do, it cannot be done by any other operator, and it is the basic, or let's say functionally complete operator, because it has the capability to derive a query by itself. So again, one more point is it's a binary operator because it's working on more than one table, thus it's a binary operator. Set difference in relational algebra is same as set difference in set theory, with the constraint that both relation should have same set of attributes. So if you remember set theory, almost it's the same there also. If there are two sets and the data which is present in one set and not present in another set, in set theory, set difference operator gives us that data. Here in relational algebra, we are doing this in form of table. Here, one important point is it has a constraint that both relations should have same set of attributes. It's nothing but your union compatibility condition. If you have checked my previous video, in union operation in relational algebra, I taught about union compatibility, and as I told there also, union, set difference, and intersection, these three operations we can perform only if our relations or the tables follow union compatibility. And first point of union compatibility is it should have same set of attributes. That means degree of the tables should be same. What is the meaning of degree of the table? If my first table is having 3 columns, my second column should also have 3 columns. So it should have same set of attributes. This is one important point of union compatibility. Notation. Notation for denoting difference. For example, we have a relation R and relation S. So this set difference is denoted by minus sign. And it is defined as at any instance in a relation R, set difference S is given by, it returns a tuple. That means the tuple T belongs to, this is belongs to relation R, and tuple T not belongs to relation S. Fine. So set difference must be taken between compatible relation. As I told, union compatibility is must. R and S, which are two relation, or let's say two tables, must have same arity. Same arity means it should have same attribute, it should have same degree. Attribute domain of R and S must be compatible. Must be compatible means it should have same domain. If my first column is taking integer value of R table, then first column of S table should also take integer value. Then only I can apply set difference between those columns. So these two union compatibility point should be there in set difference operation. Here, as you can see, for showing set difference, I have used two tables. One is table A and table B. Now, let's understand with the help of these table. As you can see in table A, we have ID and name, where ID is taking integer value and name is taking character or string value. Table 2 also we are having ID and name, and ID is taking integer value and name is taking string values. So here, if I have to find out set difference. That means if I have to do A minus B, so we will find out the row which is present in relation A but not present in relation B. That's what we want. If I'm doing A set difference B, that means I want to find out those rows which is present in relation A but not present in relation B. Now, before starting set difference, we have to check that these two tables should be compatible. Compatible, as you remember, first point, they should have same degree. So let's check they have same degree or not. Here also we have two attributes. In this table also we have two attributes, so it is having same degree. Second point of compatibility, attribute domain of R and S must be compatible. So here, as you can see, this is taking integer first column. Here also first column is taking integer, second column is taking string. Here also second column is taking string. So yes, they are compatible. So now we are allowed to perform set difference on them. So let's check which row is present in table A and not present in table B. So if I check this combination, one Ram, here one is there but Ram is not there. In this we are having one Sita. So one Ram is not present in table B. So in output table, when I will do set difference, I will get one Ram. Second row, 2 Mohan. Now 2 Mohan is present in set A and 2 Mohan is also present in table B. So this will not come because it is present in both the table. And what we are doing, we are fetching only those data or those rows which is only present in table A. We are not taking those rows which are present in table B as well. So 2 Mohan will not come. Now third row, 3 Ram. Now 3 Ram is here, but here we have 3 Sita. So again this row is not present in table B. That's why in output 3 Ram will also come. So like this we are going to write the we are going to get the resultant table. So here, as you remember, in this entire lecture video series, I am following this particular bank database. All the queries I'm solving on this particular bank database only. So here we are having 6 tables, and these 6 tables, um, the underlined columns are the primary key, and as the arrows are denoting, for example, in branch table, branch name is a primary key. For account table, account number is primary key and branch name is foreign key, which is referring to branch. Fine. So this is the bank database, and all the queries we are going to solve using this bank database. Okay, before that, just one quick point to remember. Now, what we are doing in set difference, we are computing A minus B. So here it is checking all the rows which are present in table A and not present in table B. But if you can see, this is not happening opposite. If one Sita is not there, one Sita is not coming in the table. If you can see in the resultant table, we are not getting one Sita. So it happens from only one direction. If I'm doing A minus B, it will check only those rows which are present in table A and not present in table B. If I want one Sita, if I want rows of table B which are present and not present in table A, I have to do set difference between B minus A. Then only I will get, if I will do B minus A, my output will be 1 Sita and 3 Sita. My output will be like this. So we are only taking from one direction. We are not bothered about both the table. If I am doing A minus B, I will only check what rows are present in table A. If I will do B minus A, then I will check which row is present in table B and not present in table A. Fine. Okay, so let's solve some queries on this topic. So first query is, list all the customer names who are having an account but no loan from the bank. Fine. So as you can see, what we want those customer name who are having account. Let's check the schema. If I will check the schema, so here it's asking me list all the customer name. So as you can see, customer name is present in three places. One is customer table, another is borrower table, and third one is depositor table. Now customer table has all the names who are part of the bank. All customer names are there. In depositor table, we have those customer name who have account, and in borrower table we have those customer name who have loan. And here what our query wants, here my query wants list all the customer name who are having an account. That means I'm dealing with depositor table, but no loan. That means I'm dealing with borrower table. So I hope by this time you understood how to select the tables. Fine. So for this query, first thing we are dealing with depositor table. So I'm here writing depositor. After this depositor, second thing what we are doing, second thing, list all the customer name. Now as you can see the schema, customer name is a attribute, it's a column name, and whenever I want to fetch a column name, what I have to do, I have to do project. So when I have to do project, I have to use what, I have to use pi. So I'm using pi, and customer name, that column name I have to write. So from depositor table, for projecting the customer name, I'm writing pi customer name. Similar thing I have to do with borrower table, because it's asking but no loan also, right? So loan details we are getting from borrower table. So here I'm writing borrower. Similarly here also I have to project those customer name. So I'm using again pi, and I'm writing customer name. Now, check the condition between them. Who are having an account but no loan. That means from first table, we want all the rows which are not present in second table. Correct? That means what I want set difference. So here for set difference, what I have to do, I have to put a minus sign between them. Hopefully this is clear. Next, find the name of a branch who have an account but no loan. So first find out which table we have to use, because here also if you can see, branch is also present in many places. So if we can see, it is there in branch table, it is there in accounts table, and it's there in loan table as well. So this branch name is present in three places. Now think properly. Um, those branches which have loan, those branches which have loan are coming from loan table. Those branches which are having account are there in account table. Correct? We want those branch name who have account but not loan. So that means we are dealing with what? We are dealing with account table and loan table. Correct? Those branch which have account, their detail I will get from account table, and those branches which are having loan, their detail I will get from loan table. And again, what I have to do, I have to find the name of branch. So here if you can see, in account table as well as in loan table, branch name is a column name, and whenever I have to put select or project a column name, I have to do what, I have to use project operator. So here I'm using project operator, and here I'm writing branch name, my column name which I want to project, right? And here also in loan as well, I have to project a branch name. So here also I'm using the symbol pi, and here also I'm writing branch name, right? And we want only those branch name who have account. That means from account table we want to select all those rows which are not present in table loan. That's why I'm putting a set difference between them. So I hope this query is also clear to you all. Third query, find the name of a customer who neither have a loan or an account. So if we check the schema, find the name of the customer. Now I want customer name. Let's check the schema, please. So if we check the schema, customer name is also coming on three places again. So here in depositor we are having customer name, in customer we are having customer name, and in borrower also we are having customer name. As I told you earlier as well, that depositor table have all those customer who are having account, borrower table have all those customer name who are having loan, and in customer we are having all the customers detail, right? As you can see, in customer name is a primary key for that table. So first we will fetch all the customer name, and as you know, customer name is primary key in customer table. That means all the name of the customer I will find from where? I will find from customer table. So here I am writing customer table. First thing we will deal with customer table. So it will give me all the customers name, and I want to project customer name. Customer name is again what? A column name. So I have to project it, and when I have to project it, I have to use pi, and here I am writing customer name. This is my column name which I have to write, correct? Now find the name of the customer name will come from here, who neither have loan or an account. Now we don't want loan, those customer who have loan, we don't want those customer who have account. That means we have to deal with depositor and borrower table as well. So here I'm writing depositor table, and then here I have to write borrower table as well. So here I'm writing borrower table. So my both the tables are there. Now here also what we want? Here we want customer name only. So here also let's project customer name. So when I will project here also customer name, it will come like this: customer name from depositor, and then customer name from borrower. Fine. Now when I'm saying neither have loan or an account, that means here these two will work as an internal query. So here I am putting a bracket. Now customer name from depositor and customer name from borrower. Now if what we have to do, we have to run the internal query. So data from both the table should come here. That means I have to put what? I have to put union between them. Then only the details, customer name from depositor and customer name from borrower will come together, and this internal query will run, and we will get all those customer name from these two table who either have an account or they have a loan. So all those things will come as a result of this internal query, correct? And then what we want those customer name who neither have this. That means from this resultant uh, table we have to do set difference, that means minus here with all the customer name which I'm fetching from customer table. So here I will get all those data where only those customer name will be present who neither have loan, who neither have account. I hope this is also clear. So last query on section table. In union also we have solved this query. So now with respect to set difference, just solve this query. In section table, find course ID of all courses taught in the even 2009 semester and not in odd 2010 semester. So as I explained in union also, this query is very smartly written. Here we have two condition. One, semester should be even and year should be 2009. Similarly, in the second statement, semester should be odd and year is 2010. So all this we have to take care. So we are talking about those rows where semester is even and year is 2009. And here table is not a problem in this query because it's clearly mentioning that it wants data from where. It wants data from section table. Only thing to understand here is that it's talking about rows, those rows where semester is even and year is 2009. And for selecting rows we have to use what? For selecting rows we have to use pi. So here I have to use pi. So let's take pi here. Here we will use pi, and sorry, sigma. For selection, let's use sigma. We use sigma for selection. And here my one condition is semester. In subscript I have to write what? Semester. And first condition is it should be even semester. Second thing is year should be 2009, and between them both conditions should be true, even 2009 semester. That means I have to put a and operator in between, right? So this is one condition. So I'm putting this in bracket. And what we want to project course id here. So for projecting course id, we know that what we have to do, we have to use pi for projection. So here we are using pi, and column name we have to write. So column name I am writing as course id. Now this will give me course id of all the courses taught in even 2009 semester. Now same thing I have to do for what? For odd 2010 semester also I want to do same thing. So I am writing pi course id semester is equals to odd and year is equals to 2010. And it when in between them what I want all the courses taught in even 2009 semester but not in. That means the data I want only from this table, and it should not present in this table. So here I have to use what? I have to use set difference. Fine. I hope this is clear. So this was the set difference in relational algebra. Again, points to remember about set difference. It's a binary basic fundamental operation. We have to do set difference on two tables. Set difference gives us the facility to find out all those rows which are present in one table but not present in another table. Set difference in relational algebra works same as it works in set theory. Here also it don't allow duplicates. And one uh, note or point to remember for set differences, it will work only when it two relations are union compatible. That means they should have same domain and set same degree. Then only we are allowed to apply set difference on them. So that's it for today. Thank you so much.